This is a video to demonstrate the prototype we did to show a tank scheduling optimization using LocalSearch as the algorithm. So the concept of LocalSearch is around simulating different options and solutions, and then going through and trying to improve those solutions into a score, and then picking the solution that has the best score. This is a spreadsheet that handles all the input data and the output data, and interfaces with the engine. So the first table here is the parameters. This is just having some settings around number of buckets that defines what's the granularity of the data, and the start date and end date, and how the constraints are met, and the parameter of that constraint. So for instance, demand should be fulfilled is mapped as a medium constraint with a factor of 1, and then you have minimize tank utilization as a medium constraint with a factor of 0.001. So this is something you can tweak and change the values, and try to improve the solution with the different parameters. And then in terms of master data, you have the list of tanks. So he's all the tanks that you have in your tank farm. This is the minimum capacity, the maximum capacity, and the type of operation these tanks can do. This model is set for a wort brew and fermentation process. So for the demand, you have the different product that you're producing, and the due date of that demand, and the volume of that demand. And then you go to the product list, where you have the different products, the duration of your wort process, the duration of your fermentation process, and the duration of brew process, and what is the wort product that goes into the brew, and its ratio. So once you have all the master data set up, and this is all the data that goes into the model, we'll click the Run Model button, and this will start the model. And you will see it's going to warm up. It's going to be a little bit of a time while it starts, but what you're going to see is it will start to come up with solutions and calculate a cost factor for the solution, and then iterate through the different solutions. As it gets a better cost factor, it will spit out a new solution. So here's the new best score. You can see the different scores coming in, and you can also see the count of solutions. And if I look a little bit to the left, you see the solutions per second. So what's happening here is, for every second, it's going through 6,000 to 7,000 solutions, and calculating new scores, and try different allocation for tank, different date to put that tank, and so on. And this will go through all the way until you reach the limit that you set in the parameters. So I put the limit of 1 minute, so this should be finishing pretty soon. So in this case here, I have 3 different types of constraints. I have a hard constraint, a medium constraint, and a soft constraint. And you can see the medium constraint I model as basically my demand fulfillment. The hard constraint is things that would make the solution unfeasible, and the soft constraints are things I want to maximize. So this is the result. It can tell me where it hit demand unfulfilled, or where it couldn't minimize the capacity of the tank. And this is the allocation of the tanks, so all the start and end times of each of the tank and product, and what operation they're doing, and then how much they're doing. And this is the demand fulfillment, so what product was produced at what date, time, and how much it produced. And the ones that doesn't have any date are the ones that didn't get fulfilled. So that's what hit the score here, the 5200. I can also see the score projection. There you go. So here you can see the score projection. That means that it started with a solution that wasn't really good, and it started to reduce the solution as it was trying to fit the different demands, and this will try to get close as possible to 0. Yeah, the final result is a Gantt view that shows the allocation of all the products and tanks for the different time periods. And then this is the final view of the schedule. This is a Gantt view where you can see the different tanks and the different products by the start and end date of each operations. And then you can see how it will start an operation on one tank and then move to another tank and continue the operation for the fermentation. That's it.